All right, welcome to our day 3.4 video. This is day 4 of unit 3. Okay, we are talking about triangle congruence again, but we are looking at doing some proofs with triangle congruence. And so what I want you to do is remember from the previous lesson, we talked about those 5 shortcuts, or those 5 short acronyms for showing that triangles are congruent. If you can show that there are 3 pairs of congruent corresponding sides, we can use side, side, side. Or side, angle, side, if there's 2 pairs of corresponding sides and the included angles are congruent. Or angle, side, angle, 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 side. And then for right triangles only, we have hypotenuse leg, HL. Okay? And so you might remember that from the notes on day 3, which look like this. Okay? Remember, we talked about side, 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 angle, angle, side, angle, 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 side, and HL. Okay? And we spent some time looking at when those would be applied, when we could say they're congruent by those things. Well, now we're actually going to work through these as proofs. And so I've given you some sets of possible reasons that either sides can be congruent or angles can be congruent. All right? And these are going to be important for us to pay attention to, because that's what we're going to be trying to do, is show that sides are congruent and or angles are congruent in a certain way so that we can say these triangles are congruent. Okay, we can say that sides are congruent. First of all, if it's given to you, obviously, that is a given statement that 2 segments are congruent. Okay, that might be an example like AB is congruent to CD. Okay, that's how you would say that sides are congruent. You're just going to state that segments are congruent. But then we can also use things like the definition of a midpoint to say that they are congruent. So we can use definition of a segment bisector to say they're congruent. But then this next one is very, very important. The reflexive property states that a side or segment is congruent to itself. Okay? And we talked about that a little bit yesterday. When 2 triangles share a side, that means it's congruent to itself by the reflexive property. Now, to show that angles are congruent, we have some more options. All right. Again, if it's given to you that you have congruent angles, that would be possible. We might see an example like this to show that angles are congruent. Angle A congruent to angle D. Okay, just on some triangle. But that's how that statement would look. We could use vertical angles to say they are congruent. We could use alternate interior, alternate exterior, or corresponding angles. But for these 3, you must have parallel lines. Okay? You have to have been given that the lines are parallel to be able to make those conclusions. Okay? And then we have definition of angle bisector that would also give us congruent angles. And then we also have another one. The reflexive property could also be used again if 2 triangles share the same angle. Okay? Reflexive property of congruence if 2 triangles share the same angle. So let's actually go ahead and try a couple of these. Okay, on the first few proofs we're given here, I've given you all the statements. We just have to put in the correct reasons. So I'm going to help you walk through this. The first thing you want to do is look at all the given information, mark it on the diagram, and then see which of these 5 reasons we can actually use. Okay, so this first proof, we are given a pair of congruent segments, PQ is congruent to ST. Well, that's a pair of congruent sides. So I'm just going to make a note to myself. I've got an S, okay, for these 2 congruent sides. You're also given QR is congruent to RT. QR is congruent to RT. There's another pair of congruent sides. So I know automatically it can be one of these first 2 because I have 2 S's already. And then lastly, it says R is the midpoint of PS. Well, that will eventually tell us that PR is congruent to RS, but I have to use the definition of midpoint to be able to say that. Okay, so I am going to use side, side, side. All right, and so you'll notice how they start to list these out. And notice that they do not list all of the givens in one line. They list them out separately because in a triangle congruence proof, we want to be able to use a list of these pairs of congruent sides as separate statements. So the first one, PQ is congruent to ST, that's just given. Okay? and that's one of your S's. QR is congruent to RT is also given. That's your other pair of congruent sides. And then statement 3 is the other given, that R is the midpoint of PS, but that leads me to this next line, that PR then has to be congruent to RS because of the meaning of the word midpoint. So the reason I'm going to give for that is the definition of midpoint. Anytime we say it's midpoint, then we say congruent segments, remember that means it's definition of midpoint. Okay, and so that's the other pair of congruent sides. When I've shown these 3, I can use side, side, side to say the triangles are congruent. So the next one is lining these up in the correct order. PQR is congruent to STR by side, 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 and that finishes the proof. Okay? So let's try another example. Example 2, we've got a little bit different diagram. We've got some other information that's going to help us out here. Okay? We're going to complete this proof. It's a lot shorter. You'll see the steps already written out for you. But let's mark the given information on our picture first. So we are given that JM, this side on the left, is congruent to NL. And we are also given that angle JMN, that's this angle, is congruent to angle LNM, this angle. Okay? So there's a pair of congruent angles. So I have a pair of sides and a pair of angles. Now that means that I could either use side, angle, side, or angle, angle, side. One of these 3. So I have to figure out what other information I'm given. Well, I can actually take a hint by looking at what they do in the proof. So this first statement is given again. That's a pair of congruent sides. This is your other given, the pair of congruent angles. And then they say MN is congruent to MN. Well, that's because in this type of a figure, these 2 triangles share a side, which creates another pair of congruent sides by the reflexive property. Okay, so that's your other pair of sides. Now I've written it out as side, angle, side, but it does work out that way because of the order of these markings. In this triangle, JMN, we have a side, then an angle, then another side in order. This is the included angle between these 2 congruent side markings. And then it also works out to be the included angle over here between these 2 congruent side markings. So it is side, angle, side. So I can say the triangles are congruent by side, angle, side. And that finishes the proof. Okay, let's go ahead and turn the page. Now, example 3 is another proof where I've given you all the statements. You've got to fill in the reasons. I want you to try this one on your own. Before you get to class, try and fill that in. Maybe use pencil, so if you need to fix it, you can. If you need to get some extra help from me, that's fine. Otherwise, we will confirm that that is right when we talk about it in class. But we're going to take a look at example 4 now, where we have to do the entire proof ourselves. Okay? We always want to start with marking the given information on the diagram. So here's what we're told. We're told that YZ bisects angle WYX. Okay, that's the angle at the top. WYX is this big, wide, obtuse angle at the top, and YZ bisects that, cuts it in half. So I'm going to mark it like that. But what that'll mean is I have to take another statement to say that these angles are congruent by the definition of bisector. But we're also told that angle YWZ, this angle, is congruent to angle YXZ, this angle. So I've got 2 angles listed. Okay, so it's either going to be angle, angle, side, or angle, side, angle. Well, as we look at this, sorry, I'll make that list out here. The only other information I have to go off of is that these 2 triangles share side YZ. Well, I know YZ is congruent to YZ by the reflexive property. Okay, so because the congruent side marking is not between the 2 angle markings, that is not an included side. So the S is not between the 2 A's. So I'm not going to end up using that. I'm going to use that. So let's list out our proof. All of this that I've done so far is just planning, so we know how to list out the proof. And I'm going to follow the same pattern we've been following by listing out these statements separately. Okay, so I'm going to start with YZ bisects angle WYX because it's given. And before I list the other given, if you were doing this on your own and you went ahead and listed the other given, I wouldn't count it wrong. But this doesn't specifically say angles are congruent. That leads me to another statement that angles are congruent. So I'm going to make that first before I state this. So I'm going to focus on the fact that since this bisects the angle at the top, angle WYZ has to be congruent to angle XYZ because of the definition of bisect. That takes care of one pair of congruent angles. Now the other given, angle YWZ, is congruent to angle YXZ. That takes care of the other pair of congruent angles. So all I have to do is list the pair of congruent sides, and that was because of the reflexive property. So I say YZ is congruent to YZ by the reflexive property of congruence, which makes the triangles WYZ and XYZ congruent by angle side. So that finishes our proof there. Okay, let's try one more. Let's try our final example here together. We will see what we get. Okay, we are told that triangle WVX and triangle YZX are right triangles. Okay. The only reason I would have to specify that is if I'm supposed to use HL. So this right here tells me I'm going to have to use HL. Otherwise, I would not specify that they are right triangles because HL is the only one that works only for right triangles. So they are right triangles. What they don't tell you, and what they probably should, is that these are the right angles. So go ahead and mark those. Okay? So I'm going to use HL. Well, let's look at what they give you. They say WV is congruent to YZ. That's just given. Well, those would be legs of the right triangle, so that takes care of the leg part of HL. And then it says X is the midpoint of YW. Well, YW, or WY, is the set of both hypotenuses. Sorry, I'm using wrong words. So that means that WX is a hypotenuse, and it's congruent to the other hypotenuse. So that part takes care of the hypotenuses. But because it uses the word midpoint, I have to make another statement after that saying that WX is congruent to YX by definition of midpoint. So this is what this should look like. We're going to start with our first given, triangle WVX and triangle YZX are right triangles, and you can use the symbols and abbreviations. That's given. And we have to state that so we can use hypotenuse leg. Then I'm going to use my other given. WV is congruent to YZ because it's given. Then I'm going to list the other given, and that's going to lead me to another statement. Remember, this said that the legs were congruent, so this rest of it is going to lead to the hypotenuses being congruent. Okay? Well, because X is the midpoint, that means that WX is congruent to XY, or YX, by definition of midpoint. Well, that's the hypotenuses, so I can say that triangle WVX is congruent to triangle YZX because of hypotenuse leg. All right, so we're going to do some more examples in class to hopefully make this a little more clear. There's a lot of different ways we can set up triangles and show that they're congruent, but this at least gives you a head start on how we set up these proofs.